Hi, everyone. So this is the county fair. This is not in your book, but if you want to download this lesson, you can go to Thursday's, today's, what is the thing called? The Canvas page, Week at a Glance. It's right there. So you just will need to download it. If you try to preview it, it's going to look weird. It just goes right in that cell and it's strange. But anyways, you can just use a separate notebook paper. We'll be doing this lesson for today and tomorrow. This will be on using substitution to solve system of equations. So what I did for you here is this is our do now. If you notice here, we have our cyclops. So, and here's our cyclops hiding right behind the 12. And we said that cyclops is 12. Great. We know that the fly guy is equal to cyclops plus 22. So if that's true, what is the fly guy equal to, right? And we're like, okay, this is a puzzle. Let's try and figure this out. So somebody was like, well, if cyclops is 12, then that means 12 plus 22 is 34, which means fly guy has to be 34. See what we did here? So if you want to take a look, I don't know if you knew, but if you take a look over here at number 1, see how it says x is equal to 12? Guess what? This is like x is equal to 12. And then y plus x plus 20, y is equal to x plus 22. Does this look familiar? Right? So remember, so x is like cyclops and y is the fly guy. So we're like, well, what's fly guy? Or maybe it's just y guy. So we're gonna just do like how we did with this picture one. So instead of x, we're going to put in 12. So 12, that's what we call substitution. So 12 is equal to 12 plus 22. So y is then equal to 34. See how that goes? So we know that x is 12 because it says x is equal to 12, right? So since we're now talking about x and y, we can write this as a point. So this is going to be 12. If x is 12, y is equal to 34. Okay, just like that. Who knew we were doing algebra? We thought it was just a game. All right, so if you take a look at this one on the bottom here, this one's a little bit more complicated. So we have here the elephant is equal to, let me see if I can erase some of these guys. So elephant is equal to the koala plus 3. We also know, just kidding. We also know that the koala is equal to 2 elephants minus 10. Right, so now it's a little bit more complicated. We can't just plug one into the other, or can we? Right, so if you notice right here, if I take this top equation, well, I know that an elephant is equal to the koala plus 3. Well, if I just put in what koala is also equal to, right? The 2 elephants plus minus 10. So do you see the 2 elephants minus 10? How that's equal to koala. So we literally just took out that koala and then put in the 2 elephants minus 10. Okay, same idea here. So now let's do a little bit of algebra here. And so then we're just going to combine like terms. Well, we know that minus 10 plus 3 is equal to minus 7, right? So we have 2 elephants minus 7. Okay, so what would it be? What would the elephant be if we have one elephant is equal to 2 elephants minus 7? That's still a little complicated. What we're going to do is let's just take an elephant out on each side, right? Here's my, what is it they called? Arrow. And we're like, okay, let me erase that guy too. You never saw that. It's never there. All right, so then if we take out an elephant on the left, all we have is nothing. We have 0 things there. And if we take out an elephant on the right, we just have 1 elephant left, right? So that's going to be 0 is equal to just elephant minus 7. Well, elephant minus 7 is 0. Then what is that elephant going to have to equal? What minus 7 is 0? Yeah, and that elephant would be 7. So there we wrote down the elephant is equal to 7. Now that we know that the elephant is equal to 7, it can be like 7 for days. So you could either use the bottom equation or the top equation, doesn't matter. And it'll give you the same answer. It should, and if it doesn't, then it doesn't work with the puzzle, right? So we could go 2 elephants, which is 2 times 7. That's 14 minus 10, which would be 4. Or you could do it this way. I like the top way. Some people prefer the bottom one because it's already solved for koala. But if you look at it, some koala plus 3 is equal to 7, right? So then this has to be 4, right? Because 4 plus 3 is 7. Okay, either way. So here we go. This is going to be, how do we call this? X is equal, oh, we don't have an X or Y. Oops, never mind. Okay, so this is what that's going to look like. And if you notice, I don't know if you notice, if you look at number 4, X is equal to Y plus 3. Where have we seen that before? Elephant is equal to koala plus 3. Y is equal to 2X minus 10. Koala is equal to 2 elephants minus 10. We were doing algebra. I was just fooling you. You guys know. I didn't tell them that. Or did I? All right, and so we're going to try another equation right here. So if we know that X is equal to Y, and we also know that Y is equal to 2X minus 10, well, how can we solve this equations? Could we figure out what X and Y are that fulfills both of these conditions? So what I notice here is that the X is equal to Y, right? X is equal to, says X equal to Y, right? So instead of this, or I guess you could do for either one, but I decided we're going to just replace the Y with X, okay? So I'm going to be like, I'm going to just replace that because I know that Y is equal to X. So now I have this equation right here where it's X is equal to 2X minus 10. Now, what we're going to do, okay, this just goes back to algebra. What is it? Algebra, the last unit. So you can either subtract X on both sides, or you can subtract 2X on both sides. I decided to subtract 2X on both sides. And what do you get? You get negative X is equal to negative 10. Well, how do you get rid of that negative? Remember, we can either multiply by -1 or divide by -1. This is the only time where you can get rid of a multiply by multiplying, right? Because -1 times 1 is just 1. So that doesn't change the value. So here, we're just going to get X equal to 10. And so if X is equal to 10, that means Y has to equal 10. Because why? X is equal to Y. Exactly. So this is our point, 10, 10. So in the other universe, let's say we decided to, I'm going to just go X is equal to 2X minus 10. So we decided to subtract X on both sides. Let's just say. So then we would just subtract X on, oops, oh well, that's fine. And we would get 0 is equal to X minus 10. We get exactly what we had before with the elephant, right? We're like elephant minus 7 is 0. So which means that elephant has to be 7, right? So X minus 10, if that's equal to 0, that X better be 10 because 10 minus 10 is 0. Or you can algebraically solve it if you're like, I don't have, I can't think about that right now. So the way we get rid of this minus 10 is plus 10. We get 10 is equal to X, right? Same thing. So it doesn't matter which way you do it. You can do it either way. Either way, your answer is going to be 10, 10. And remember, the X always comes first and then the Y. And some people may think of that like Pokemon XY, right? You don't say Pokemon YX. That's weird. All right. So we're just doing a few of these, writing these equations down because that seems to be the hardest one. So, okay, so Janet, she has a mom who is making a whole bunch of potato salad for this county fair. And so she's like, Janet, I want you to go and get some onions and potatoes because apparently you need onions and potatoes for potato salad. Do I put onions in mine? I put green onions. But yeah, maybe I put some onions. Diced it really small. All right. And so, and she gives her $30 for this, right? And she also knows, let's see here, that, oh, from before, sweet onions per pound cost $1.25. I feel like that's a little high, but you know, maybe it's the farmer's market. I don't know. And the potatoes cost $1.05. All right, knowing that, and she has to use the $30 as much as she can. So we got 125 X plus 1.05 Y. Because remember, X, I wrote it over here. X is talking about the onions, the number of pounds you're buying onions, and Y is going to be the number of pounds for potatoes. And altogether, that's got to be $30. All right, so that's our first criteria. We know this has to be true. She's not buying anything else. All right. And then the next thing that Janet tells her is that, because how much onions and how much potatoes, like you do the even amount, like X equals to Y kind of thing. Or I'm thinking you probably need more potatoes than you do onions, right? So if you notice right here, it says that the number of pounds of potatoes should be 8 times greater than the number of pounds of onions. I hope so, right? You should have more potatoes than onions, or else it'd be like a potato onion salad. That'd be weird, but maybe it's good. I don't know. I've not tried it before. So Y is equal to 8 times X. Now, some people may be like, well, why don't you do it? X is equal to 8 times Y. Isn't it supposed to be 8 times greater? Let's think about this. So remember, this is my onions, right? So whatever my onions is, my potatoes have to be 8 times bigger than that, right? So that's why we multiply the onions with the 8, okay? Because we want 8 times of whatever the onions is to be my potatoes, okay? So if it was 1 pound of onion that we bought, then we would have 8 pounds of potatoes, right? Because we want to make potato salad, not wheat, Janet's mom. All right, so there we go. We're going to kind of go on down here. We graphed this on the, what is it called? On Desmos. Let me get that for you. Let me pull that up right here. All right, so let's see here. Here is Desmos. And so if you look at right here, 1.25x plus 1.05y is equal to 30. Just plug them right in. If you notice our intersection, okay, so this is what it looks like. I did not actually graph this on paper because I'm like, I kind of didn't want to do that. So if you look at the intercepts right here, what does this one mean? Where that red line crosses the x-axis. So this one, red line talks about the money, right? So if we spend 24 pounds, remember my x was, what was my x again? Onions, I want to say. X is, yes, x is onions. So if we want 24 pounds of onions, we could buy 24 pounds of onions for 30 bucks, but we'll have no potatoes. Not a good idea. Or if you look on the other side, remember the y, we could buy no onions and 28 and a half-ish, half and some change of pounds of potatoes, which would be great. But then, you kind of need the crunch of the onions, right? So we want that happy balance, remember, where it's 8 times as much as the onions. So here we go. So we should buy for 30 bucks, we should buy about 3.1 pounds of onions and 24.9 pounds of potatoes is what we should get. So let's try that out. And so this is our intersection. We rounded them because, I'm not going to write all of it down. And so that's what we wrote down. and we tried doing this algebraically. I'm sorry. All right, so what you're going to do is we have these 2 equations, and we're going to figure out what x and y are. So I noticed that y is equal to 8x, right? That's a pretty simple one. It's already solved for y. So I'm going to be like, well, instead of y, we're going to just put in 8x. So that's why I put it right here, right? And so now we have 1 equation with 1 unknown. We can solve that. We've done that last time. And so here, I'm just going to multiply these guys out. So 1.05 times 8x is going to be 8.4. And now we're just going to combine like terms because they both have x in them. So 1.25x plus 8.4x is 9.65x, combine like terms, because they're both on the same side of the equal sign, right? And now I'm just going to get rid of this 9.65, divide that on both sides, and I get x equal to 3.109. This looks so familiar, right? So this was our x that we got before. We just rounded it to 3.1. And then how do we get the other one? Plug it into, you can either plug it into the bottom equation, top equation. I would pick the easier one. So I think the bottom one is the easier one. So that's what I'm going to do. So y is equal to 8 times 3.109. I would not round it here. Do not say 3.1 here. I would get as close to around as little as possible. But if you do have to round, then I would just go with 3 decimals or 4 decimal places. Okay, that's usually pretty accurate enough. And then so we're going to go 8 times 3.109, which gives us 24.872, which we would round that to about 24.9. Okay, so that's how that's going to go. All right, and so algebraically, we saw it like visually with the graph, right? It's that intersections where those lines cross or they meet. That's where the solution is. We did it algebraically. We used the substitution method. We'll learn next week another method. In case we don't want to do substitution. Can you always use substitution? Yes, you can always use substitution. I will say most people will probably use elimination. Oh, I gave it away. Use the other method. You didn't hear that. Use the other method just because most equations are written in standard form as opposed to a slope-intercept form. But you can do, again, either way is fine. right? And this is a worked out example that if you've downloaded the document, you can just look at that again. I'm gonna go with this one. So here we have another scenario. We have Samson and Adrian. Now, they want to earn a little bit of extra cash, right? So they're gonna set up booths at the fair. So they just need to get the wood and carry it to the different places so they can build their booth. So, and they're getting paid $7 an hour. Apparently, I don't know if this was before the minimum wage thing, or maybe it's outside of that church. I don't know. But anyways, $7 per hour. So Samson arrives at 7 a.m. early in the morning and begins working immediately, like the good worker that he is. And Adrian's a little bit, I don't know, maybe he's later, maybe he said he's going to come at 90 minutes later. I don't know, but arrives 90 minutes later and starts working. Okay. So here we go. Says, write Samson's, like how much he's going to make. So Y is how much he's going to make altogether is equal to, like, what's his check going to look like, right? 7 hours or $7 per hour, right? And X is the number of hours. So 7X. So how much money will Samson earn after 90 minutes of work, right? Because remember, he works a whole 90 minutes before Adrian even comes. So that's the $7 per hour plus, half of it, right? 30 minutes left over, right? Or you can do, I guess, 90 minutes. So it's 1.5 times 7. Either way, but that's going to be the $10.50. All right. So how much money is Adrian going to get? He's going to get the same amount almost the same amount as Samson, except we're going to subtract 10.50 from it because that's the 90 minutes. Remember that he wasn't working. So it's going to be whatever Samson's is minus $10.50. Okay. So now we have these two. And the question is this: will Adrian ever earn as much money as Samson? Assuming they end at the same time, yeah, no, they're never going to, it's always going to be, Samson's going to always have 10.50 more, right? That's the way it's going to be. So if you look at how much money will the students earn by noon, so if you think about it, how much time has passed? So from 7, 8, 9, 10, 11, right? That's going to be 4 hours, right? Ooh, this might be a little bit different. Maybe they set up anyways. So, so it's just 4 times 7, which is going to be $28. So after working all morning, Samson is going to get $28, right? And what's his name? Adrian is going to get $10.50 less than that, right? So that's going to be minus 11. That would be 17 plus 50 cents. So 17.5. So $17.50. Is Adrian ever going to catch up to Samson if they end at the same time? Never, right? It's not going to happen because it's always 10.50 less because he was just not there 90 minutes. If he wanted the same amount, he should have come at the same time as Adrian, right? And so what is this equation going to look like on a graph? You think about it. Let's just think about it. Actually, no, I can just draw this. So here, if you work no hours, you get no money. Remember, this is your hours. This is your money, how much you earn. Not you, but these people. And so it's going $7 an hour. So every 7, so it's going to look something like this. Adrian, remember, started later. So he's going down here at 10.50. He loses out on this 10.50. But earns the same, the rate is exactly the same. So do you see how, like, at any given point, this distance is always 10.50, right? Always 10.50, right? But as you notice, they're parallel. So if we were to solve these, it would be no solution. Like we said yesterday or the day before, the last lesson, I should say. So let's try and solve this algebraically. If that's not a 2, that should be a 7. X, Y is equal to 7x minus 10.5. So now let's give it a whirl. Okay, I know I'm kind of deviating from here, but they do actually want us to do it algebraically too. So if they're both equal to y, right, I'm gonna just set these equal to each other. So 7x is equal to 7x minus 10.5, right? Bring this guy, put it there. right? Because they're both equal to y. Now I'm going to subtract the 7x because I'm going to get this x's together. And I get, what's 7x minus 7x? If you have 7 x's and you take away 7 x's, how many x's you got left? None, 0. Right, so 0 is equal to, so that's the same thing over here. We get 0 is equal to negative 10 point, what? X's go, right? And so notice, is 0 equal to negative 10.5? No, not equal to. So when in this case, you're like, it's not, yeah, not equal to, we say no solution. Okay? Even with the graph, if you get a graph that they're parallel, like the question is, the solution is when the 2 lines cross. Well, do the 2 lines ever cross? Which means that there is no solution, meaning they never cross, ever, period. All right. All right, and that was the end of where we made it, I believe. And we'll finish it up this lesson next time. See you later. Bye.